Hi everyone, it's David again, and today I've got a bit of a different video. Today I'm just going to show you how to actually install Arch Linux. I know there's plenty of tutorials, and there's plenty of articles about it, but I figured we'd go through the official installation instructions, and I'll talk you through what each of the parts does, and how to decide how to customize it and what to do with it, because there's a lot of different parts that can be a bit confusing, so I'll just walk you through it. Okay, cool. So as you can see, I'm on this website, so it's archlinux.org. So if you literally type in archlinux.org, it'll take you to this website, and then all you'll want to do is download the ISO. So you click download in the top right, and you can either download it via torrents, so as a torrent. So magnet link will just give you the magnet URL, and torrent will just download the actual .torrent website, the actual .torrent file, which you can then use. Alternatively, you can just download an actual ISO from web mirrors. So if you scroll down, there's a bunch of different mirrors for a lot of different countries. So just pick the one that's closest to you, or if you can't really find one that's good, you can go for just worldwide mirrors. They're probably based in the US. I couldn't tell you at the moment, but they probably are. For me, I would go down to United Kingdom, since that is where I'm based. Just scroll down until we find it. There we go, United Kingdom. So just click any one of them. Just whatever. Just go for servicebase.co.uk, why not? Okay, well, that seems to be dead. So I just clicked the very first one, allworldit.com, or allworldit. And it'll take you to this kind of website. It's basically just a directory of a directory. It's directory of a folder, think of it that way. And then you'll want to download the ISO. You can alternatively also just download the .torrent from here, or you can download this version. So these are basically identical, but this is more of so this is the latest release, and this is what I have, so 11.01. I've re-downloaded it today to make sure that I've got the latest version. Okay, so once you have this downloaded, you'll want to either put on a USB stick to install it on a physical machine, or if you're going to be doing it in a VM, in a virtual machine, you can just do it that way. So I'll show you how to get it on a USB stick, and then I'll install it in a virtual machine because the installation instructions are practically the same. Okay, so if you're on Windows, you can use a piece of software called Rufus. So go to rufus.ie, and it'll get you this. So then you'll just need to download it. So go to download and just click either that or that. I prefer the portable version because you don't need to install it. Just download it and run it. It'll basically give you a thing like this. So where it says device, this is where you pick your USB device. Boot selection, so this is just where you would pick your ISO image. Image option, it'll determine it automatically, and these as well. I'm not sure if it picks the target system correctly, so you will want to pick UEFI most likely. So UEFI is Universal Extensible Firmware something interface, maybe, which is the newer version of what you would know as BIOS, which stands for Basic Input Output System. So once you pick those, it'll pick everything else correctly, or at least it should do, and you just click start, wait for it to finish, it'll tell you it's done, and that's it. An alternative, if you're not on Windows, for example if you're on a Mac, or if you're on a different Linux system, is to use Balena Etcher. So Balena Etcher, so just go on that, and then you can just download this. This will be very simple. It'll tell you literally select an image, select the drive, flash. That's it. An alternative to that is to actually use DD. So you can use DD. Obviously, there's nothing there. So to use DD, you'll need to give it the input and output. So what you can do is you can do DD. You can do if. So this is input file. And then you'll give that, say, dev SDA, right? And then an output file of, this is where you want to copy to. So I actually messed that up. So if will be input file. So let's say on Windows, it'll be something like this. Users, David, I'm on Windows right now, so desktop, and then say Arch, tab for some reason doesn't work. But it'll be basically that file name. So it'll be Arch Linux. It'll, in essence, just be this. Right? So paste that, and then you do of, and this will be your actual USB. So what you can then do on Windows is you can do that. But obviously, you probably won't have DD on Windows. I have it for various purposes. So in your case, this will probably be something like dev. It could be, if you have it mounted, it might be not even under dev. It might be somewhere like MNT, USB, whatever you mounted it as. Or it could be deb. It could be dev slash, say, I don't know, USB 0. Or it could be a block device, whatever. In which case, obviously, your if will also be something like home, your username, arch.iso, and then of will be, let's say, dev SDA. And then for progress monitoring, you can also give it status progress. It'll tell you how it's progressing. And then you can also give it a BS. BS is block size. So how basically a block size is how much data is it going to copy at once. So you can do as little or as big as you want. In some systems, a very large size might not work. On some systems, a very small size might not work. So generally, you can do something like 1496K or just 1496 in general. If I was to do it, I'd probably go for 100 megs, so 100 megabytes a second, or per transfer. And then that'll run. So obviously, if I do that, it'll say no, nothing found. Alternatively, you can also just extract it into the actual USB stick with the proper file system on the USB stick. And if you don't know what your what your USB stick is called under your system, you can use fdisk. So it'll say bad usage, but fdisk, this will be it. So fdisk -- list, not fisk. Fdisk -- list. For me, it's not gonna really show anything. It's just gonna do this and then not show anything. But on your system, you'll actually get a list of attached disks. So both removable disks, so a USB stick or a portable hard drive, and actual SATA disks or other interface disks. Okay, cool. So once we have that, I'm gonna be using VMware Workstation 16. It's not too expensive, so I use it for virtualization because it has a bunch of different features, and it's pretty cool. So for me, obviously, you click create new virtual machine, typical, fine, and then you just go to the file, you pick the actual Arch Linux system here, and then just click next. So under guest operating system, pick Linux. So it doesn't have Arch Linux on here for some reason. So we'll just pick other Linux 5.x and later kernel 64-bit. And then just call it whatever you want. I'll call it that. And then I'll just store it under a different system, under a different disk, sorry. Why do I keep going to desktop? Under here, and then under here, we'll go to VMs. There we go. And then we just click next. And this is the disk size. So ideally, for an actual system, you'll want, if you do intend to use this, a VM, if you're doing it on a VM, then you'll want this to be a reasonable size. So let's say, for the sake of this, I'll do 20 gig. Or actually, let's do 50 gig. Generally, this will be enough, but it depends on what you're intending on installing and what your actual use case is. So do consider that. And then what we'll want to do is we'll want to customize hardware. And I'll want to just give this 1496, so that is 4 gig. I don't know why I just pressed enter. And then on here, what I tend to do is I just tend to give it 2 processors and 2 cores. So that'll result in 4 cores total. And then display, we don't need to accelerate 3D graphics for now, but everything else is fine. All of this is good. I'm just going to give it 3.1 just in case. And then finish. Then wait for that. There we go. So let's go into settings. And then just to make our life easier, I'm going to set that to UEFI, since that's what you will want instead of BIOS. And then also disable side channel mitigations for Hyper-V enabled hosts. Okay. So this will in essence just speed it up, because side channel mitigations are, well, side channel mitigation is generally a good feature. However, if you're not going to be in an environment where you actually need that kind of security, you will want to turn it off to make sure that it's not impeding your progress. So then we just click OK. And then we launch it. There we go. So you hit that. And then so you'll be prompted with this sort of menu. So to navigate this, use your up and down arrows and select the first or the second option. If you select the second option, it'll just give you a screen reader. So if you need screen reader, use that option. I'm going to pick the first option and just press enter. So again, navigate with your arrows and then pick the first option. So Control Alt to get out of this. And then while this is booting, what we'll do is I'll just go back. And then we'll go to the top and click Installation Guide. So this is what we'll be following, and this is what I'll show you. So obviously I've already actually verified stuff, and I don't need to check things. I'm fine. You can do this if you want. It's very easy generally. You can just run this. On Windows, you'll need to install GPG and then download the signature file, as you've seen before. So if I just go to, just pick any one, and then what you'll need to do is just download the .sig file. Okay, cool. So let me just go that, installation guide. I'm sorry if you can hear my fans. I do have industrial server fans on my PC. Okay, so this will basically just show you that what you have is legitimate. However, the problem with this is that if the file can be manipulated, so can the actual image. So can the actual signature file, I mean. Okay, so this shows you what we've done. So prepare an installation medium. So this is what we've just done. Boot the live environment. This is what we've also just done. And it's just telling you various different things that you can do. So the first thing that you can do if you need to is set the console keyboard layout. So this in essence chooses your input scheme. So if you have a keyboard that's not like a standard, say, US keyboard. So for example, for me, I have a British keyboard. So if I try to go for, say, an @ I get double quotes. If I go for double quotes, I get an @ right? If I go for a pound symbol, I get a hash. So that's what that is. So running this, so ls stands for list, this will show you different available key maps. So for me, I know that I need to type loadkeys.uk because I know that there's a file called uk.map.gz. Run this and it'll show you a list. So let me show you. Right, so ls/usr/share/kbd/ what was it? Keymaps /************************************************************************ and this will give you a list. So if you're running this on a VM, you will not be able to see the whole list. You might be able to see it on if you're booting this on actual hardware. You may not. It really just depends, because sometimes it lists it in columns, sometimes it just lists it as a single list. So what you can do for this is do this, space, vertical bar, which you will probably need to get. But for me, so I'll just do load keys UK to get my bar and where I need it. So the vertical bar for me is in the bottom left corner to the right of the shift and sort of above and to the right of the control button. So if we just type that and then vertical bar, and then what we do is grep, and then I'll type in UK, and here we get UK. So you can see that there is a UK keyboard, which is the 4th item on the list. So you can see USR, share, KBD, keymaps, i386, QWERTY, uk.map.gz. And that's what we want. Okay, cool. So you can do that. So what this does is grep stands for regular expressions. Well, regex is a regular expression, but grep is one of the tools that allows you to find things with regular expressions. However, since we're not using a regular expression, it'll just match those two characters. And this vertical bar simply means that send the result of this command to this executable. So by executable, I mean a program. Since grep is a program, you're in essence just running a program. Think of it like double-clicking an icon on your desktop, and that in essence just opens that, except that we're doing this in a terminal, right? So just do that, and then just do your thing. For me, it's load keys UK. Cool. So next, you can also set a font if you wish, using set font. However, we're not going to be doing that. So now it's telling us to check if we have UEFI enabled or EFI. So it says to verify the boot mode, list the EFI vars directory. So I know that I have UEFI set up in the VM. However, I'm still going to just check it just to be sure. So I'll do ls/sys/ firmware/EFI vars. So what I'm doing here is I'm also pressing tab, so you can see that you'll get auto completion. So if I type EF, I can press tab and it'll auto complete the command for me. If there's multiple options, it'll give you those multiple options that match the the characters that you've already entered. So I press enter and I get a bunch of files. So we don't need to worry about them, we just need to make sure that they're present. So this just shows that we do have UEFI and not BIOS. So now we know that we're going to be following the UEFI specific installation steps. So just just write clear. I do like to clear my terminal just so it's not cluttered up. Clear just means clear output in essence. It clears the screen. Think of it that way. So it says if the command shows the directory without error, then the system is booted in UEFI mode. Cool. So that's what we've got. So we're going to be following UEFI. Okay. So connect to the internet. To set up a network connection in a live environment, go through the following steps. So I know that because I'm connected via Ethernet, I already have a network connection. So I don't need to worry. So I can type IP link and it'll give me all the details. Right? I can just do IPA, and that'll give me another set of details. Fun fact, you can also do IP add, IP add, IP adder, IP addree, IP address, and IP address. Any form of address will give you the same output. It's just a fun little fact. Cool. So in your case, you might need to use things like IWCTL to configure things. Whoops. So you might need to do that or do another command. So for example, you might need to use mmcli if you're connected to a mobile broadband modem. But for me, since I'm connected to Ethernet, or at least the VM thinks it's connected via a cable, I don't need to do anything. So once you've set stuff up, you can just then check that you actually have an internet connection. So we'll just do ping-google.com. And you can see that we actually have a connection. So another thing with this is that this will just keep on going for a while. To stop it, what you need to press is Control and C. And then you'll get that little sort of hat and then a capital C. And that'll just show you that you've stopped the program. That goes for anything, for any program that you're running in a terminal. Okay? So next, it's telling us to update the system clock. So for me, it's probably already going to be up to date. However, we can just check. So enter time, date, CTL, status. So it says system clock synchronized. Yes. NTP service active. So NTP is network time protocol. It's the next step. So what this does is it'll in essence use servers online to configure your system's clock. So the next step is to then make sure that stuff works properly. It used to be on here, but it's not on here anymore. So if for you this says if the line that says NTP service says inactive or disabled or something along those lines, what you can do is you can do time date CTL set NTP true, and then it'll come up as active. If I set that to false, for example, and then enter status, you can see it says inactive. So I'll just set that to true. And you can also navigate through your history, so your command history, by just pressing arrows up and down. It's one of the wonders of Bash. And then if you want to see the commands that you've entered, you can simply type history and it'll give you the commands. Anyway, so the next step is to then make sure that obviously the system clock is correct. The next step, excuse you, that was my Amazon device, whose name I'm not going to mention for obvious reasons. So now what we need to do here is to check what disks we have. So it says when recognized by the live system, disks are assigned to a block device such as dev SDA, NVMe ON1, or MMC BLK 0. So we can then use fdisk/l. So just to explain the difference between these. So SDA will be your standard sort of SATA devices. NVMe will be an NVMe drive, and MMCBLK will be pretty much everything else. It will more often than not be a logical partition of a hard drive or of an SSD or whatever else, right? So you can then use fdisk-l to just check what you have, or lsblk as it said. So it'll give you this. But fdisk/l is significantly better. -l is what I meant. There we go. So you can see that we have two devices. We have /dev/sda, and we know that it's 50 gigs in size, so we know that's the correct one. It'll give you the disk model, it'll give you the size, and everything else. Dev loop 0 is so this is the mounted CD as it considers it. So it's the ISO in essence, right? So it's 671 megs in size. So that's the ISO. You can actually, I don't know if it's mounted. No, it's probably not mounted, so we're going to ignore that. So we know that we have that. So what we need to do now is we need to type fdisk/dev/sda, and it'll give you this. So you can see that it'll give you a bunch of information, and you can type M for help. So what we need to do now first is to make sure that our disk doesn't have existing partitions. So what we can do is type P for print, and you can see that there's nothing on there. It just says disk/dev/sda, and there's no other partitions on it. So what we need to do now is create some. So this will handily give you some information on what you need to do. So for a general system, you'll probably want a very basic sort of setup. So something like this. If you're running with BIOS, you can use this. Or if you need some other things such as RAID or any other sort of systems, file systems, then you can configure it however you want. But I will be following this. So it says that we need mount boot, which will be EFI. So this is where our boot files will be stored. Swap. So what swap is, it's sort of like paging in Windows. So all it is that when your computer runs out of RAM, it will start using that swap space to act as sort of supplemental RAM. However, your operating system, or in this case Linux, will more often than not simply use the swap space. Even if your RAM isn't fully saturated, it'll just use it just for it to be used. There's a specific parameter that actually determines whether or not swap will be used. It's called swappiness. And it's set to 50 by default, I think, which means that half of the time it will be used and the other half it won't. So it in essence just determines how frequently this swap space will be used. So swap will be a partition on the disk, so it'll use that disk space to fill in for RAM. Okay, and this will just be your system root, so think of it as the C drive in Windows. So what we'll do now is we'll press G, well, enter G, press enter, and it says created a new GPT disk label, and that's exactly what we want since it says UEFI with GPT. So GPT stands for something that I don't remember, GUID partition table. There we go. And it says it right there as well. Create a new GPT disk label, GUID, and then it gives you the actual identifier. So that's good. Now we actually need to create partitions. So to create a partition, do N. For the first partition, just press enter. Then first sector, enter. And then for the last sector, we need the size. So at least 300 megabytes. So let's just do 310. So what we can do is enter plus 310 M. So plus 310 megabytes. Press enter. So it says create new partition 1 of type Linux file system. So we know that that's the wrong file system. We want it to be EFI. So what we can then do is press T, And then obviously there's a bunch of different partition types. We can list them all by just pressing L and going up and down using arrows. However, thankfully, the one that we need is number 1, EFI system. So to exit out of this menu, all you can do is just press Q and then partition type or alias 1. It says change type of partition Linux file system to EFI system. Cool. So what we do is we repeat that again for the second one. So N. So partition number default 2, enter. First sector, enter. Last sector. So for this we'll do we'll just do 1 gig. Generally, the common consensus was that swap space should be half that of your RAM size. So this virtual machine has 4 gigs of RAM, so we would need 2 gigs of swap space. However, that's not really true anymore, as the kernel has, the Linux kernel has sort of been developed and swap has been almost rewritten in a sense. Its functionality, and a lot of systems no longer really rely on swap as much. And you could probably even run a system without swap and it'd be fine. However, some legacy software does rely on swap, and the only reason swap exists, it's because this was created in addition. This was created to supplement old systems. So when a system didn't have as much RAM and you wanted to run applications or software that used more system RAM than you had, you would use swap. So that was sort of software RAM in a sense. So it's like that meme where people say download more RAM. This is in essence what that is, except instead of downloading, you just create some. Okay, so plus 1G, so 1 gigabyte. Press enter, and then says Linux file system, since that's the default. We don't want that. We do T again, default 2. So it will always default to the highest number for both N and T and pretty much every other command that relies on creating things or editing things. So we just press enter, and we just press L again. We figure out what the one that we need is. So I can see there is number 19. So 19, 19. So that's Linux swap. Cool. So we press Q, type 19, enter. And the same for the rest. So N, enter, 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 and then enter for this as well, unless you need to reserve some space for something else. I want to use up the rest of the file system, so I'm just going to press enter, and then I'm going to press T. We do that, then we type L, and then we need Linux root. So this is number 23, Linux root x86-64. So then we type 23, enter, and then making sure that everything's okay, we just press P. So this is what we currently have. Make sure that it's all good. I'll just press W and press enter. So W stands for write. So it will write the changes to the disk. So we do that. It says the partition table has been altered, calling IOCTL to reread partition table syncing disks. So that means it's done. And just to make sure, you can run fdisk-L, and you can see that we have those changes now. So what we need to do next is actually mount those. We need to partition them first. So here you'll see format the partitions. So I'm going to be using ext4 for the main one and FAT32 or F32 for the EFI system partition. However, you can use other file systems if you so wish. ext4 has been around for a while, and is generally a good choice if you're just experimenting with Arch Linux and want to see what's going on. So what I'm going to do now is I'm going to type mkfs. So mkfs stands for make file system .ext4. So this is the Linux sort of Linux's own file system in a sense. It isn't, but for the sake of this, just consider it to be that. So mkfs ext4, and then you see here it just tells you that all you need to do then is just specify the partition. So we know that this is dev SDA3, and it'll give you a bunch of information. And the reason we know it's dev SDA3 is because when we run fdisk-l, it actually tells you that dev SDA3 is Linux root. And that is what we want that to be. So that's all correct. So just clear the screen. Then the next one that we can do is we can do swap. So the swap space. So for that, it's mkswap, because swap isn't a file system per se. So there's a separate command. Well, swap is technically a file system, I suppose. But the command is mkswap, make swap. And then we'll do dev sda2. Okay. There we go. Setting up swap space, version 1, size 1024 megabytes. No label, UID, etc. Okay. So we have that. Then the next one that we need to do is mkfs.fat, then -f 32, and then we'll do the only remaining one, which is dev sda1, right? Yep, that's correct. So dev sda1. Brilliant. So here it'll just give you a bunch of details, such as the date that this was released, or, well, it's probably more so the compilation date of the software, when it was actually compiled from the programming language into an actual usable piece of software. So now what we need to do is actually finally mount them. So generally in Linux, you will want to use mount to mount things. So mount will mount things and umount will unmount. So generally you will need root permissions for this. However, we're already root, since this is a live environment. Nothing is yet installed into the system, so we're just running as root already. So what we'll do is we can actually just type swap. I keep wanting to say swap instead of swap. So we'll do swap on /dev/sda2. And it'll give you no output, which means that generally that's fine. And then we'll do, again, mount /dev/sda3, and then where to mount it. So we'll just do /mnt. Okay, so now we can do ls/mnt. So ls, again, list, and it automatically created this directory called lost plus found. Okay, so now the last one that we need to mount is the boot directory, which is also listed here. So mnt boot. We can pass the mkdir flag. Mkdir stands for make directory, or you can create it using mkdir as a separate command. However, we'll just do that since it's faster. So we'll do mount --mkdir dev sda1 and then /mnt/boot. Brilliant. So since that's done, we have it mounted, and now what we need to do is actually install stuff. So installation is very sort of particular to your own use case. So this is probably going to be the most difficult decision, I suppose. But I'll explain why. So now we need to install a bunch of software. So we need to install the actual operating system. So we need to install Arch Linux itself. So we'll use this command. So pacstrap. So pacstrap is part of pacman and pamac. So pamac is the actual package manager. Pacman is the utility to manage the packages. By packages, I mean software. And pacstrap is sort of the pre-installation tool that you use to install the system with. Okay, so we'll use this command to install base. So base is the base utilities. Linux will install the actual Linux kernel and Linux firmware for other things. You can actually click on these things and it'll tell you what stuff is. So for base, you can see here it says minimal package set to define a basic Arch Linux installation. So we'll do that. Okay, so we do pacstrap -k/mnt, where to install it into. Then we do base Linux and then Linux firmware. So there's actually multiple sort of Linux kernels. So there's Linux, which is the sort of like the most default Linux kernel available. There's Linux-hardened, which comes with a bunch of sort of security modifications and other considerations for security. And then there's also Linux LTS. So LTS stands for long-term support. It's a slightly outdated version. However, it gets long-term support by the developers, right? So we'll just press enter here. And it'll just do a bunch of things. And you can see that it's quite big. So it's 870 megs in total. And then when that's done, you'll have a very basic installation. So we'll just wait for this to finish. And then in the meantime, while this is happening, we need to consider what else to install. So obviously, just these 3 packages or pieces of software aren't going to do you any good, because you're not really going to have a useful system. So what we can do is go through the packages that exist in the live image. So the ISO that you downloaded comes with these packages, and this is the file that contains these packages and their versions. If you want to install any of them, ignore the version here. So version is likely going to be numeric at the end, and just enter that. And if you don't know what any of those are, what you can do is, if I just go back to this, you can go to here, so /packages, or just packages in here. And in the keywords, you can enter, let's say, I don't know what DRBL is. So we enter DRBL, and then we get this. And then it'll tell you what this is. Diskless remote boot in Linux. Manage the deployment of GNU Linux operating system across many clients. Okay? So generally, you'll want to install at least some of them. And that is going to be about 4 to 6 gig, depending on what you install. Okay? So you can see that it says stuff has been installed, and ignore those warning messages. They're just relevant to some specific pieces of hardware that you may have, or in my case, don't have. But more often than not, stuff will work absolutely fine. So what we can add is, just to go through the list, let's actually make a list here. So, and then we can just go through it. So what we'll need is ACL. Then we can also go for ATTR, which is attributes. Then audit. So audit will allow you to audit your sort of security and who ran what command as super user, etc. Then I'll also install bash. So bash is the sort of the set of tools that you get to actually interact with the system from the command line. Then you'll also probably want BC. Then we'll need bind, and then just a bunch of other pieces of software. So I'll just pick a bunch of these. Actually, on top of bash, I'll install ZSH, which is an equivalent of that. So then we'll install dbus. Actually, before I forget, we'll also install these things. So mandb, manpages, and techinfo. So mandb, manpages, and techinfo. So this will be man. So man is in essence manual. That's what that stands for. So you can access manuals for almost every single piece of software. Obviously, the ones that come with their own sort of documentation by typing man and then the command. Okay, so just do those, then go back to this. So I'll just pick a bunch of options here. So this option here, Intel U code, is specific to processors running Intel. So Ucode, it's not actually U, it's actually the Greek letter mu. So Ucode is microcode. So in my case, it'll be Intel. If you're running AMD, in that case, it'll be AMD-Ucode. Okay. Okay, so here I have a list of individual packages to install, and this is exactly what we're going to do. So I've just gone through this and just picked a bunch of different tools. You don't have to install all of them now. You can install a bunch of them later. However, installing them off the bat will make your life significantly easier. I've actually missed 3, which is CA certificates, so I'll just pop that to the end. Whoops, just go to the end and then just add CA certificates, Mozilla, and CA certificates utils. Okay, so all of these will give you different sort of utilities, and you don't need to install all of them because you will not use all of them and they'll just occupy space. Actually, one more thing that I didn't add was Avahi. Okay, brilliant. So this is all we need, and then we'll just add base, Linux, and then Linux firmware, because I'm going to add this onto here. Okay, so what I'll do is, I'm not sure if I can paste stuff into here. So what I'll do is we'll just go through this: base, Linux, etc. I'll see when I've typed it all out again. Okay, so here we are. Some tools are not found, so you can see about midway through it says error target not found, GDPalm, and this is what will happen. So if it doesn't find something, it'll fail the whole thing. So you'll need to just go all the way back and find that one that you've messed up. So in my case, it's HDPalm instead of GDPalm. So just go back to here. There we go. And it's HDPalm. And then go and reinstall stuff. So the reason it's reinstalling is because a lot of these packages are part of base. So base is what's called a metapackage. A metapackage is one name for a collection of packages, such that when you install something that's related to each other, or something that provides one functionality or a set of features, then instead of installing each and every one of these pieces of software individually, you install a meta package that'll download all of them. Okay, so let's just wait for this to finish. It'll take about a minute. Okay, so this is now done, and we can close that. And then what we do next is we do this. So generate an fstab, or fs tab actually. I like calling it fstab, but it's actually fs tab, which stands for file system table. File using -u or -l to define by UUID or labels respectively. So UUID is much better than labels because labels can be changed. Well, so can UUIDs. However, UUIDs likely won't be changed by the user, whereas labels are sort of human names. Okay, so we're going to follow this. So gen fs tab dash u. So we go here, gen fs tab dash u slash mnt, or slash mnt, right? Yep. So then we do this. So this is in essence redirection. So one of these symbols, which is a more than symbol, so one of these more than symbols is in essence also redirection. However, two of these means redirection of all output, if I remember correctly. I'm not sure. I don't remember. In essence, all that this does is it'll write the output of this to the file. However, if you run it without it, you'll just get this text. So all this will do is it'll, instead of giving that text to you, it'll put that text in the file. So we do /mnt /etc etc /fs tab. No extension, nothing. So no .txt or anything, just that. And then you won't get any output, and that's all you will need. So we know that the output is correct because we've already actually seen it. So we've seen it before, so we know that it is correct. You can change those if you want, if you know what you're doing, but I'm not going to be going through it here because we don't need to. So just clear. And what we now do, and this is the first time using the system, so what we'll type is arch-chroot. Chroot means change root. So instead of using the live, quote-unquote, live file system as the root, we'll now use the installed file system. So arch-chroot space /mnt. And now we get that here. Okay, so now you can see that this is our system. Okay, so we know that we're now in the system. What we need to do now is we can actually skip a lot of this stuff and go straight to here. I'll go through it because it is important for an actual proper functioning system. So set the time zone. So ln means link dash. So everything after dash is considered a flag. It's in essence a way to change the functionality, the default functionality of any program. And this isn't exclusive to ln, which stands for link, but it goes for everything. So -s means soft, and f is force. So soft and then force. So ln in essence makes a symbolic link. So it's sort of like, I don't really know how to explain it, but it'll in essence create this file, so in directory etc, and then instead of making this file an actual proper file that takes up space, it'll instead make it refer to whatever this file will be. So whenever you read this file or edit it, you'll actually be editing this file. Okay, so that's what we'll do here. So we'll do ln-sf, and then what was it? USR share zone info. So USR share zone info, and then country. What was it? Region, right? Region, not country. Yeah. So in my case, it's Europe /city. So that'll be London, and then we'll symlink that. It's called symlinking, symbolic linking, to etc local time. I think it's local time, right? Yes, local time. There we go. So that's done. And now the next thing that we can do is run hwclock to generate etc/adj time. Right, so adjusted time. So hardware clock, system to hardware clock. So you don't need to run this if your hardware clock, so your BIOS, your UEFI clock is accurate, but it does help. In my case, it's not actually going to do anything because this is a virtual machine, but I'll still show you. So hardware clock --sys to HC. Give it a sec. There we go. So what this does is this sets your UEFI clock to match your system clock, such that it basically improves security and a bunch of other things that rely on timing. Okay, so we'll just clear that again. And then, yeah, you can see this command assumes the hardware clock is set to UTC, which it generally will be. So next we'll edit etc locale.gen and uncomment this. So this is obviously specific to ENUS, so English United States. However, in my case, I'll uncomment 2 of them. So to edit things, I prefer to use nano, which is this. You can alternatively use VI or Vim. So Vim is improved VI, and VI is just VI. However, I prefer to use nano. So in my case, I'll type nano /etc /locale.gen, and it'll open this. So to navigate around text in here, just use arrows up and down, left and right. To search in nano, what you can do is press Control W, and you can see at the bottom there's a new bar that says search. So in my case, I'll do EN US and then press enter. You can see it'll get highlighted for you, and then your cursor will be moved there. So all we need to do is uncomment this. So everything in this file, everything that's preceded by this hash symbol is considered a comment, so it gets ignored when this file is read. So I'll delete that hash, and then I'll do the same again. You can see it also shows your old search, so we do Control W again, and then I type EN_GB. And then we have that, and we can uncomment that. Then to save stuff, what you can do is press Control O, and it says file name to write. By default, this will be the same file name, so just press enter, and it'll say wrote 507 lines. Alternatively, you can just press Control X, and it'll ask you if you want to save it. Then you type Y for yes, and then press enter. Because I've just saved a file, it didn't ask me because there were no changes to save. So I'll just clear that. And then what we do is do locale-gen. So locale-gen. You can see it'll say generating locales, and then generation complete. There we go. Cool. So it'll in essence just generate locales for this. Okay. So next it says create the locale.conf file and set the lang variable accordingly. So you can see it says etc locale.conf. Okay, so that's what we'll do. So we'll do nano /etc /locale.conf, and we'll be given an empty file because you can see that at the bottom in the middle of the screen it says new file. So the file doesn't exist, and we'll create it. So what we need to do here is type lang in caps, then equals, and in my case I'll do en_gb.utf-8. Okay, so you can see it says it here. It wants you to create it as ENUS, and you can do that if you're based in the States, or if that's the keyboard you have, etc. So now I'll show you how it works with Control X and saving files. So if I press Control X, it'll say save modified buffer as a question mark, and it'll give you 3 options: yes, no, or cancel. So in my case, I just press yes, and then it says file name to write. Same, and now we do the same thing. Simply just press enter, and it saved it. You won't get any output. That's all you'll get. It just saves it, and that's it. So this is optional, but we can do it. I'll go through it just to cover all bases. So it says if you set the console keyboard layout, make the changes persistent in vconsole.conf. So that's what we'll do. So we'll edit that file. So etc vconsole.conf. So nano /etc /vconsole. Sorry, vconsole.conf. And this will also be a new file. And then what we'll do is we'll type keymap as it says here. And instead of doing DE Latin 1, we'll actually set a slightly different one. There was a list of it somewhere. Where was it? Console fonts. Yeah, there we go. So it says console fonts are located in here and can likewise be set with set font. So this is what that will do, but automatically, this file. So we click console fonts, and there's a bunch of information here, but all we need, realistically, is we can just go here and read through this. So preview and temporary changes, and you can have a look at console font screenshots. This will give you sort of an example of what console fonts look like. So the console fonts will be used when your computer is booting. You'll get a bunch of just output before you get to the login screen. Okay, and a bunch of other things as well will be using this font. So what we can use here is, since I've actually installed the package Terminus font, I can select a font here. So what I will select is Ter 116N instead of 132. So 132 is a size, but I'll select 116. Or I can do 120. No, I'll just do 116N. Okay. So if we go back to this, we'll do keymap equals Ter equals dash, sorry, 116N. And then we can do the same thing, Control X, Y, enter. And that's it. Okay, cool. So next, we need to actually call our computer something, such that on the in the network, you can see what computer is what, and that it'll be able to talk to other devices using its name rather than just solely by the IP and MAC addresses. So what we'll do is nano etc hostname, and then this is just where you enter the name. So what I'll do is I'll just do arch-vm, same thing, Control X, Y, whoops, Control X, Y, enter. There we go. Okay, so that's all that's done, and it says complete the network configuration for the newly installed environment. And you really don't need to do anything here because everything will be set up later on. So network configuration, it takes you to stuff here, and you can follow this if you need to, but I don't actually need to. So we'll just go on and go to initramfs. So this is, in essence, your boot. This is how your PC will boot. So it says creating a new initramfs is usually not required because mk init cpio was run on installation of the kernel package with pacstrap. So this is when we installed all of these packages. Okay. However, we can do it anyway, just to be on the safe side. So we'll do mk init cpio-p. Okay. So mk init cpio, whoops, cpio-p. It'll give you a bunch of output that we've already seen before. So we'll wait for this to finish. There we go. So that's all done. Brilliant. Next, all we need to do now is set the root password and install a bootloader. Bootloader. There we go. So since we're logged in as root now, we can just set root's password. So we type PASSW, so password, but instead of word, it's WD. So new password. So my password will be password, and then it'll ask us to repeat it, password. However, obviously don't use password as password for your system root account. That is very, very insecure. And then once you press enter, if those two passwords are the same, it'll tell you that password was updated successfully. Brilliant. Cool. So next, we need to actually install a bootloader. So a bootloader is a piece of software that runs when you first start your PC that actually launches the operating system. And you can have many operating systems installed and just have one bootloader. For example, on my main machine, I actually have, so I've got Grub, which is what we'll install, and I have Windows installed, and I have Debian. I also have memtest86, but that's just a memory tester. However, it runs as its own sort of operating system, quote unquote. Okay, so next it says choose and install a Linux capable bootloader. Okay, so we can click here to see some installation instructions. We will pick grub because, quite frankly, grub is probably one of the best choices so far. So we just click on grub, and then we can just scroll down and then just go through these steps, which are somewhere where I don't remember. UEFI systems. Yep, there we go. So it says mount the EFI system partition, and in the remainder of the section substitute ESP with its mount point. So we already have that. It is slash boot. It used to be /mnt/boot. However, since we have sort of quote unquote logged into our actual system, it has now become /boot. Okay, so that's what we need to do. So we now just type this. Actually, we need to install it first. That is one thing that I didn't tell you. So it says first install the packages grub and EFI boot manager. I've already done that. However, we'll just do it anyway, and I'll show you how to install packages in the system itself. So what we'll do is first we'll type pacman -$SYY just to update stuff. So this will download the package cache or repository cache. So a repository is where all of the packages are sort of stored centrally. Okay, so we'll do that, and then we'll do the same, similar thing. We'll type pacman -s, and then we'll type grub space EFI boot mgr. Okay, and then we'll just press enter. So when you get a question like this, and then in angle brackets you have multiple letters, and if a letter is capitalized, that is usually the default. So you don't need to actually type it, you can just press enter and it'll consider it to be Y. Okay, brilliant. So what does this say? To use the new features provided with this grub update, that's fine. Not too concerned about that. Okay, so we can just clear that again. And then we can just follow the steps here. So choose a bootloader identifier, here named grub. A directory of that name will be created to store the EFI binary, and this is the name that will appear in the UEFI boot menu to identify the grub boot entry. Okay, so here we can just use grub. We don't really care, or at least I don't care about the name. You can pick whatever name you want, however, it can't have spaces. Okay, and generally just make sure it's capitalized and makes sense. Okay, so what we need to do is grub-install. So grub-install, we do --target equals x86-64-EFI. This simply means that we're using UEFI on an x86-64 platform. Okay, so next we need to do EFI directory. So we then do --EFI-directory equals, and in our case it is /boot. Whoops, I have not picked an identifier. That's fine. We can just do the same thing again. So just press 1 up. So using arrow keys, press up, and then grub. Was it grub identifier? Bootloader ID. Bootloader -ID equals grub. There we go. So now we can just go to /boot. So to change directory or to go to a specific folder, you do cd, and then you can just do /boot in my case. And then here we have information. You can now see that we have grub, so we can do cd grub, and then to list, we just type ls, and you can see we have stuff there. And then to go back to the previous directory, if you went from one directory to another directory within that directory, if that makes sense, you can just do cd ... So dot is the current directory. If you type that, nothing will happen. If you type cd ... it'll go to the parent directory. So if we type ls again, you can see that. So we have a bunch of files here. We have grub and we have EFI, so we can go to EFI, and you can see we have some stuff there. So we can also go to grub in here, and you can see there's stuff there. And to go to your home folder, so think of it as being C users David, for example, on Windows. All you need to type realistically is just cd, and I'll go to your home directory. Okay, so we've done that. The next thing that we need to do is just to make sure that we actually have the relevant files, unless they've already been created. Let me just double check. It doesn't always create it. Sometimes it does, other times it doesn't. It's a bit weird like that. Okay, so it didn't. Okay, fine. So what I'll do is here, we'll type grub /mk config -o for output. So this will be the output file. We'll do /boot /grub.cfg. Okay, and it'll give you a bunch of these sort of pieces of information. Okay, so that's all we need to do. When it says done, that's it. Now what you type is type exit to exit out of the changed root. So we're now back into our ISO, into our sort of USB / CD disk system. Okay, so just for security and safety and system safety, what we'll do is we'll type umount -r, so for recursive, so unmount everything, and we'll type /mnt. Okay, and now all we do is type reboot or reboot, and then we just wait for that, and here we are. So this is grub. It's very plain, but that's all you need. Realistically, there's a timer unless you press something, so there's a couple of second timer, and you just wait for it to finish, and then all we do is we just press enter, and then this will take a second. There we are. So you can see we're running Arch Linux kernel version 6.0.9, and what we need to do is now log in. So type root and password is password. Brilliant. So just to make sure everything's up to date, we can do pacman syy. Oh right, okay. What we'll need to do first is, because there's something I didn't do, is type dhclient. Okay, so I've made a really stupid mistake here, and I'll be back in 1 second. Okay, so we're back. I'm back to the login screen, so same thing, just log in. One thing that I didn't do was when we ran the whole pacstrap command, which won't exist here. So when we ran that, one thing I didn't install was a package called dhclient. So dhclient is DHCP client, so it automatically assigns the IP address. So now what we do is we type dhclient, and all we need to do now is just make sure that the internet's back up. So there we go. So clear that. So all we need to do now is just type pacman syy just to update stuff. And now we actually need to install a desktop interface, right? So there's many that you can choose from. So there's GNOME, which is what's used by Ubuntu. There's LXDE, which is a sort of very lightweight desktop environment. So if you're low on memory, you can use LXDE. However, for me, I'm going to install KDE. So for KDE, you need to install multiple packages. Okay, so to install the said packages, what we need to do is type pacman. Pacman actually stands for package manager. Alternatively, you can type pamac, but just use pacman since pacman is the actual package manager for Arch, where pamac is sort of like the back end. It's the actual sort of system tool that does all the handling. -S stands for sync instead of install, so synchronize. And then what we do is type plasma, and then it'll give us a bunch of sort of packages that it's going to install, and then we just press enter to install all, and then you can pick one or the other here. However, we're just going for the default, which is jack 2. So this is for audio. So you can pick whichever. Jack is fine. Pipe wire jack is also fine. But for sort of better configuration, I suppose in this case, we'll just go for jack 2. So just press enter. This is for fonts. So you can pick any font that you want. So there's GNU free fonts, Noto fonts, etc. You can also install all of those fonts if you wish. So if you want to install all, just type all. But in my case, I'll just press enter. So here, this is the sort of session manager. So in Linux, there's two sort of important tools when it comes to audio. There's the audio provider, so which is sort of the tool that runs, that actually gives you audio, and there's the session manager. It's difficult to explain what a session manager is without going into how Linux deals with audio, but all you need to know is that you need those two tools. So in my case, I'll just press enter, and then for Qt5, we'll pick the default phone on Qt5 GStreamer, and then it'll say that it'll install all those packages, and then it'll tell us how big the download is and how big the installed size is. So the reason there's a difference between these two sizes is because it downloads archives, so compressed packages. So again, you can either enter Y and press enter, or just press enter to select Y by default, since if you remember what I've said before about the capitalization, Y is the default option. So we just press enter and it'll just install it. Okay, so we'll just wait for that to finish because we'll need to install one more thing after this. So just wait for this to finish. So as you can see, the download is going quite slow. We're downloading at about 1,800 kilobits a second. And I'll tell you why that is. The reason it's downloading quite slowly is because it's going off of the very first sort of mirror available in the list. And that mirror is probably based somewhere in the United States. For me, that is obviously on the almost on the opposite side of the world. So what we can do is, we'll do this after, there's a tool called Reflector. So a reflector, in essence, will test multiple different mirrors, and it'll then rank them in order of speed. And then, so the closest one to you will probably have the highest speed. I should also probably explain what a mirror is. So a mirror is, in essence, almost like an archive. So there's multiple mirrors across the world that in essence host the same thing. So they're like copies of sort of like the master repository, just to provide access to the packages, to software, to everyone. And so people installing Arch, and this isn't actually exclusive to Arch, mirrors are used in a bunch of other distributions such as Ubuntu, Debian, Linux Mint, etc. So mirrors are often provided free of charge, and so what that means is that if you have 100 people downloading stuff at the same time, you can very quickly rack up a bunch of bills in essence for network use and internet. And it can also make speeds very, very low for a bunch of those people, because you're having to share that bandwidth with those 100 people. So mirrors exist to also provide sort of higher speeds for people. And as you can see, we're currently at 82 out of 400. because we're probably downloading from quite either a slow mirror or a mirror that's far away from us. And obviously this will depend on your internet speed as well. I have about 200-300 megabit a second, so it's quite decent, but when it comes to downloading stuff from the other side of the world, it can be quite slow. So we'll just wait for this to finish, and then I'll explain what Reflector is and how to use it, and then we'll install the other piece of software, and that will be all. So as you can see, the download is now done, and we are now installing all of that software. Depending on your system, it will generally take a couple of minutes, I'd say, on a slower system, and on a faster system, it can take anywhere from 30 seconds to a minute to 2 minutes. I have, I'd say, about an average system, so mine is going to be about a minute, 2 minutes for installation. So you can see it's nearly done. We're at almost 400 out of 437, so that's that. We're now running MK initcpio again, so just so we can have the latest installation. So MK initcpio or initcpio in essence just rebuilds your Linux image, which is just your Linux kernel, with all of the, let's say, well, modules is the word. I was going to say patches, but patch is a different thing, so I couldn't come up with the right term. It in essence just builds that and generates all of the relevant sort of files for your system to boot. So we've done that. So we've downloaded those files from Plasma. So Plasma is a meta package, as I've mentioned at the beginning of the video. So if you now think about those mirrors again, what we need is Reflector. So Reflector is probably not installed. Yeah. So what we can do is install it. We can do pacman-s Reflector, and then we'll just install it. And now we have Reflector. So we can run Reflector, and it'll give you a list of servers. So what we can do is we can use those manual pages that we've installed as part of the bootstrapping, at the beginning, using pacstrap. So we can type man Reflector, and you'll get a manual page for Reflector. So you can see it says retrieve and filter the latest Pacman mirror list. So it doesn't really give you a bunch of information, but there are some examples here, and you can see you have Reflector, -- country, H12, protocol, sort, save. So that's exactly what we're going to do. So instead of having to remember that, what I'll do is I'll type it out. So we'll do Reflector, -- country. From my experience, for me, it will be Netherlands, France, and I think it's UK. Yeah. And then we'll do protocol, HTTPS. So instead of HTTP, we're going to use HTTPS for security. We'll do -- sort, rate. So this will be the speed. And then we'll also do -- save and follow this. So pacman.d. So pacman.d is where Pacman stores its files. So .d is .daemon. And I'm not going to go into that because that's computer terminology, and if you want to figure out what that is, just look it up, Google it. Quite frankly, it's not that difficult to understand what daemon is once you read up about it. Then we'll do /mirror list. And that's about it. So to exit out of this, we press Q and just clear the screen, just for the sake of it. And then we'll just do that. So Reflector, -- country. We'll just do it the other way around. UK. Netherlands is the next fastest. Then France. And then we'll do -- protocol, HTTPS, -- sort, rate, -- save, etc, pacman.d /mirror list. Just make sure that I got that right. Yep. Cool. Now we just press enter. And now we'll just wait a second. It'll take some time to run. And you might see some errors, which are absolutely fine. It just means that you can't access those mirrors. Some mirrors may be down. Some mirrors may be running maintenance, etc., etc. Because they're all run by independent institutions. Some may be run by private people. Some may be run by companies. Some may be run by universities, etc. So you can see it says here, failed to rate HTTPS download. And that's fine. So we have that here. And it's finished, right? So that's fine. We now have an updated mirror list according to our needs. So what we do now is we'll need to install another piece of software. So pacman -s and sddm. So sddm stands for Simple Display Manager. Right? And then we just press enter. Apparently sddm is already installed, but we'll just reinstall that just for the sake of it. Okay? Cool. And that's this installation done. However, we're not done yet. If you reboot now, you'll likely just get this very screen. Okay? So there's one more step. Okay, cool. So that's done. Now, what we need to do is make sure that those are installed and running. So what we'll do is we'll type systemctl, stands for system control, status, sddm. It'll probably say not running. Yeah, so it says disabled. So what we'll do is instead of status, we'll type enable. There we go. And that's basically it. However, you might have also by accident installed GDM if you wanted to install GNOME, which is GNOME Display Manager, because GNOME comes with its own display manager. So what we'll do is type status GDM. It says unit GDM not found. Brilliant. So that's that. Now, another thing that we can do to make sure that we're not logging in as root constantly, because that'd be quite bad for security, and some software might break if you're logged in as root. What we'll do is we'll create a user. So, to create a user, you type user add. We'll do -m. -m means create user home, and then our username. So for me, it'll be David. There we go. So you won't get any output. In Linux, if you don't get any output, it usually means that stuff has worked fine. If you get something out, read it, and if it says something about failure, then that's failed. But generally in Linux, if you don't get anything back, it means it's all fine. Okay? And the next thing that we need to do is make sure that we are an administrator, that we can access root privileges. So what we'll do is we'll type vsudo. Okay, so it says no editor found. So that's because vi doesn't exist, but we do have vim. So we can either install vi or we can use nano, because nano is generally my preferred tool. So there's two options. One, which I'll do now, is to just type editor equals nano vsudo, and you'll get this file. So then we just go to the bottom. You can just hold the down arrow until you get to the bottom, and look for user privilege specification. So you can see that root by default has all. So my preference is to use wheel as the group. So you'll basically add the user to the wheel group, and then anyone in that group will be able to run administrator commands, right? You can also use sudo if you wish. However, I do prefer to use wheel. So there's two options here. So it says uncommon to allow members of group wheel to execute any command, and then the same thing without a password. So generally, when you type sudo, which means super user do, you can run any commands as the user root. However, you will be prompted for a password. You can uncomment this, like so, to run stuff without a password. However, for security reasons, I will run stuff as as a root, sorry, with a password. So we'll just uncomment that, and then we'll just press Control X, Y, enter. Okay, so that's fine. And now, if you type groups and then your username, you can see that you're only a member of a group called the same. So user David is part of the group David, because you always get, whenever you create a user, the system creates a group that's called the same. So what we'll do is we'll type user mod, so user modify user, -a, so for add, capital G, so AG, AG for group, and then we'll type the group name, so wheel, and then the username, so David. See, no output. However, if we now type groups David, you can see that now David is a member of a group wheel. So what we do now is we can just simply reboot by typing reboot. Okay, so we just wait for it, press enter, so we don't have to wait for the timeout, wait for the system to start up, and here we are. We are running Plasma under X11. There's another option, instead of X11 or Xorg, you can use Wayland. However, the last time I've checked, there was limited support for Wayland, and some things didn't work. I found I remember another thing that I didn't do. So one thing that you need to do whenever you create a user is to set a password, because by default you can't log in without a password for security reasons. So I just pressed enter and you can see it says login failed. So if you make that mistake, one thing that you can do is press Control Alt F4. Is it F4? F3? F5? F6? What is it? Sorry, I was holding the wrong thing. Yeah, Control Alt F4, and you'll get this terminal back. So you can just log in as root again, and we can set the password. So to set a password for a user once you created them, or even if you want to change a user's password, what you do is type PASSWD, so password, and then the username. So new password, we'll just set it to password. Repeat that, there we go. So that's fine. We can just log out by typing exit. And then to go back to the graphical bit, you press Control Alt F1, and we're back to this. So now we type in password, and we get our system. There we go. Oh, we even have them. Fair enough. Sometimes it creates things and they don't work. Oh, right, file manager. That is because we didn't install applications. So you get some things, but you don't get everything. So what we need is we need to install KDE 5 applications. It's another meta package. So what we'll do is we'll just go back to Control Alt F4. We can log it back in as root, and then we'll just do pacman s KDE 5 dash applications. It's not KDE, it's Plasma applications, isn't it? Is it KDE dash Plasma applications? KDE 5? No? Okay, bear with me 1 second. There we go. So it was KDE applications. It's not KDE 5 applications. I just forgot. So what this is a meta package that installs the default Plasma, well, not Plasma, but KDE/Plasma applications, such as a file manager, a terminal, etc., etc. You can install all those manually, but using a meta package is significantly better and just easier. So we do that, and then we just press enter for default. We get a selection for Qt5 Python bindings. I would just recommend going for the default PySide 2. If you want PyQt5, that's up to you. Just go. I would just go for the default. So we just press enter. Same here for cron. Just go for the default one, crony. Same thing here. Press enter, and now you can see that we get another 3 GB install. However, it's only 923 megs to download, and this time it will go significantly faster. What is this? Too many errors from mirror. Did we break our mirrors? Let's check. Cat. So cat is another useful tool. Cat will print the contents of any file, right? Generally text files, but you can do that with pretty much any file. If it's a binary, so an executable, so a piece of software, you're not going to get anything useful. You're just going to get a bunch of garbage. So we'll do etc pacman.d/mirrorlist, and you can see we have that. So, and you can see how it was generated. So the problem here, one thing that I didn't use is age. So because some of these might be old, so we'll just rerun that. Reflector, country, UK, Netherlands, France, it's comma, France, protocol, HTTPS, sort, rate, age. We'll just do the default 12 that was in the example. --save etc pacman.d mirror list. Failed to retrieve. Oh, right. It's dhclient that we're after. There we go. So we'll do that again. Just to make sure that those mirrors are up, we'll just rerun this with age. I should have probably done this earlier, but it doesn't really matter, to be honest. It should work either way. So just wait for this to finish. It'll take a couple of seconds. Okay? Cool. So ignore those warnings. It's because some mirrors obviously are down. So what we can do again is list that file, and you can see that it has slightly changed and that the command has changed. So what we do now is go all the way up. So I'm just pressing arrow up and just go through the same thing again. Just press enter a bunch of times. And now it will install it. And you can see that it's going significantly faster. So we'll just wait for this to finish. There we go. So we're done with the installation. So that's all we needed. And another thing with Reflector is that it has a lot of actual arguments. So what you can do is type --help, and it'll give you all of these arguments that you can do. So for example, instead of country, like I've done, what you can do is you can do --fastest, oops, and this will test all of the mirrors and pick the fastest ones, and then you can specify how many you want. So for example, let's say 10 or 20, and then you can also specify what score you want them to be. So it's out of 100, so you can do score 100. So it'll pick 10 best mirrors that have scored 100. And then if you run that, this will run through all mirrors, but I don't really use the --fastest because this takes a lot longer, and it's just best to pick a few countries around you, or in case you're based in the US or Canada or say Russia, probably not Russia nowadays, but say US or Canada, you can just use country and just write US, Canada, and it'll pick the fastest mirrors around you from those two countries. if you're down south, you can say also enter Mexico, or you can add other countries around you, depending on where you are in the world. So hence why I don't actually use this, because being based in Europe, you have a lot of countries around you, and running it as fastest does take a lot longer, as you can see, and you get a bunch of warnings because some mirrors are down, others don't, others are under maintenance, etc, etc, etc. There's a bunch of different reasons why I don't use -- fastest, but this is another thing that you can use. So I'll see you when it's done. Okay, so this is now done, and let's just clear that, and we can actually have a look at what mirrors we have. But the reason I don't use this is because this is very slow. You can see we've picked several mirrors, but that's why I don't actually use this this sort of these arguments. Another thing to mention, not strictly relevant to this, but as you can see, if I type reflector -- help, I get this, right? However, if I type reflector -h, I also get the same thing. So a single dash, so a minus, and then h is equivalent to -- help. So two dashes usually mean that there's going to be a word, and a single dash usually means that there's only going to be a single character. Now this isn't always the case, but this is the convention. Okay, so all we need to do right now is just make it easier. Just reboot into the actual system. So just wait for this to boot up. So you'll get a bunch of output here. Don't worry about that too much. So here we have our login. We enter the password, which is password. We're presented with this. And you can see we've got our time. We've got other things. So we've got our disk, which is fine. And now we have a file manager, as well as other things installed. So that's instant messaging, that's contacts, audio volume, it's just muted. We have two different things configured for some reason, but you can see we've got audio. There aren't any applications here, but we've got that. We've got a microphone that's not configured right now, but you've got a bunch of things here now. There's about the system, there's software updates. You can see you've got stuff here. Storage devices, other things, a firewall. Firewall is not actually installed, but it does say to install a firewall such as UFW or firewall D. I do like UFW, so what we can do is we can open a terminal, which is called console, and then type sudo. So in this case, because we're logged in as a user that's not root, we need to use sudo, and we'll do pacman-s UFW. And then you'll just get this message as for the, when you use sudo for the first time. So we just enter our password. Let's press enter. So the thing with dhclient is you don't need to start every single time. But what we do need to do is we need to do sudo systemctl enable network manager. There we go. So now we won't need to run dhclient every single time, but we do need to start it after enabling it. You can also do enable and then -- now. That will also enable it. So we've now started it. You can see wired connection when activated. And now we can install UFW. Takes a second. Can open that again. And now we have our firewall. Can enable it. So this just prompts you for the password, for your user password. but you must have administrator privileges to enable stuff like that. You can also customize your theme. So for example, Breeze Dark, just click apply and you'll get a nice dark theme. You can also get new themes, you can download them. That's why I really like KDE, because of how easily customizable it is. And I believe it comes with Firefox. Oh no, it doesn't come with Firefox, but you can install it. So another good thing is that if you don't have something, and if you type it in here, it'll tell you that you can download it. Can I open AppStream? Okay, so that's other things. I'm not too worried about that. Sometimes it breaks, sometimes it doesn't work, but it's just like that sometimes with installing packages. So what we can do is, I also don't use Discover, and while you can use Discover, I generally don't recommend using Discover, because more often than not it just breaks. I prefer using the terminal. So if we open the terminal and then do sudo pacman s, we can install Firefox. So just enter the password. It'll install Firefox. You can also install Chrome. I believe there's two different ones. There's Chromium, which is the sort of not Google's Chrome, but it's sort of like the compiled code version itself. So you won't have things like Google login and synchronization. And there's also Chrome-browser, if I remember correctly. So you can install that as well. I do prefer using Firefox. I'm one of those weird people that actually uses Firefox instead of Chromium or Chrome. But it does seem to work significantly better for me, because it just has all the extensions that I need and all the other things as well. So generally when you're installing a piece of software, it will install all of the dependencies that you need as well. So you can see that we're not just installing Firefox, we're also installing Adwaita, icon theme, AT-SPI2 core, desktop file utils, etc, etc. So all of those will also be beneficial. So if you do want to use Discover, you should install a backend, and it does tell you here that you need to install the optional dependencies. Now I don't use Discover, and even in my system I get this warning or this error because it tells you that it doesn't come with it. And you can see here it just takes you to BBS Arch Linux. So it comes with its own browser called Conqueror. I don't recommend using it because it's just not good, but you can if you want to. So once we've installed Firefox, we can open Firefox, and here we have Firefox. So you don't actually need to do this, and if we want to use Google, we can just use Google. We can actually also change the resolution here, but I don't really need to. And the reason we can do that is because I've installed a package called open-vm-tools, which allows you to just use the integration significantly better. And that's it. Now you have Arch Linux with KDE. Okay, well, thanks for watching. It was a bit long-winded, and I've had to remember quite a few things. I don't usually tend to talk, as you might imagine, when I'm installing Arch or any other operating system. So sometimes you just forget things because you're focusing more on sort of speaking and actually making coherent sentences rather than installing the system itself. So you do tend to forget a lot of things. But here we are. You've got Arch installed. I might remake a video on Arch again at some point in the future, but for now I'm happy. And as always, if you have any questions, just feel free to ask, either in the comments or shoot me an email or message me on Twitter. And that'll be that. Thanks for watching. Bye-bye.